So, ladies and gentlemen, my name is Kouloud Fakfak, PhD student from Central Lille in France, and my contribution in this international conference is a paper entitled Ontology for Overcrowding Management Emergency Department. So, my presentation consists of 5 parts, which are the general context, then the methods used, the results found, and an overview of the discussion and the validation parts made in this work, and finally a conclusion and perspective. So I start with the general context of my work. So the department of a hospital responsible for the provision of medical and chirurgical care to patients arriving at the hospital in need of immediate care. So emergency departments are often faced with the pressure of overcrowding, which pose a significant international problem. Crowding may have a negative impact on patients at various stages of the emergency department journey, as increased wait time, risk of mortality, and lack of hospitalization units. So, how we can solve this problem? So the patient journey starts with the registration and arrival at the emergency department, then the triage step, and finally the passage to the consultation. However, an overcrowding situation can dispute this whole process, increase the risk and mortality and reduce the quality of care. So the question that arises is how can we predict and manage its situations? So first, the increase in unscheduled arrival and poor coordination between the emergency department system and the MC were found to be two main factors in the inability to manage overcrowding situations. Then, in the step, the triage nurses specify the degree of severity of a patient and define the primary medical observation, but the risk of error is very high because the decision is subjective. And finally, the patient will be sorted and directed to the first consultation with the doctor. So, therefore, a crowding management ontology based on a score that predict tension situation is a potential solution to develop a hospital decision support system dedicated to emergency departments. So, first we note a necessity to avoid ambiguities, organizing the clinical data and taking into account the correlation and the semantic of critical emergency situations. This requires that we define a demand ontology that is the best solution to define the emergency department situation. For that, it should be investigated the high-level characteristic of the emergency department situations and match overcrowding scenarios to medical resources. The objective of this study are, first, we manage knowledge to properly build the adequate representation mode. Then we make knowledge accessible and usable so that healthcare staff can predict and manage the overcrowding situations, and provide healthcare personnel with a new score to properly classify emergency department situation according to their overcrowding status. So the proposed method is composed of two parts, which are the emergency department overcrowding management ontology, and the IDMO ontology based on overcrowding management process. So the emergency department overcrowding management ontology is based of three models: domain models, case model, and reasoning model. So the domain ontology model provides 7 main classes. The situation classes present the generic classes of their and define the scenario of different crowding or normal situation in the emergency department. Causes classes define the factors that can causes overcrowding situation in the emergency department. Patient classes present specified data on the emergency department patients. Classifies the overcrowding classes, classify the different situation according to their level of overcrowding. Solution classes proposed instant solution to help healthcare personnel manage this situation. And evaluation classes allows the exact evaluation of a situation at a given time according to well defined performance indicator. And finally, context classes define the internal and external environment of the emergency department. And the ontology, this ontology is defined by a complete dictionary of the hospital emergency. It is presented by classes properties to define the relation between the classes and instance to create the scenario of real cases. And here is a table that presents an overview of the properties defined in IDEMO ontology. So, the case model presents a detailed description for each emergency department overcrowding situation scenario containing all data. Here I set up the case model by defining real emergency department case scenario. And to improve the communication between the case model and the domain model, we integrate these situations, cases into the ontology and throughout the data and the object properties. And after creating the domain model and the case model, we define the reasoning model to realize a functional ontology and to integrate into a decision support system. We use the semantic web rule language, that is a rule language for the semantic web, combining the OWL language and rule markup language to create all possible scenarios of the emergency department situation. And here is an example of a thorough rule that describes emergency department situations. So, the IDEMO ontology is based on overcrowding management process that is composed of 3 steps. Firstly, to identify the performance indicator and calculate the overcrowding estimation scope. Then to classify the emergency department situations into 4 states: normal state, degraded state, critical state, and very critical state. And finally, to propose adequate action to manage the different levels of overcrowding. So the overcrowding estimation score is calculated by this formula and is computed based on the performance indicators. The RSK is given for each performance indicator according to its emergency state in this table. And in collaboration with emergency physician and based on the work of Kadri, I have identified 6 performance indicators that can predict a tension situation appropriately. firstly, the PWT is the waiting time between the hostess taking charge and the first medical examinations. T2 is the waiting time from the hostess and the nursing consultation. NP is the number of patients present at the emergency department when a new patient arrives. And PME is the ratio of the number of patients present at the emergency department to the number of doctors potentially available. And KS is the ratio of the actual stay time in the hospital of a patient in non-emergency state and the theoretical stay time. And finally, the CT indicator is the percentage of the current load at time T. It is the ratio of the number of patients present in the emergency department, and it is maximum capacity, taking into account the inflow and the outflow in emergency department. So, the OSC score is proposed to accurately assess the level of crowding in the emergency department. This score is computed based on performance indicator according in this table. So, based on cadre works and in collaboration with the health specialist, we selected the following action according to two categories with our patient flows and resource according to the level of overcrowding specified in the previous step, that are the action on the care load flow, which are incoming patient flow, decrease of incoming patients, and patient flows admitted to the emergency department. Apply priority rules to better manage patient flow in the emergency department to limit waiting times and length of stay. Transfer patients from short-term hospitalization unit to other department and adjust the care provided to patients. Emergency medical service and short-term hospitalization unit. And for action on resource, so you are is composed two types of resource: human resource by add doctors or nurses depending of availability in other department, and medical resource by transfer one or two short-term hospitalization unit rooms in consultation rooms. So now I move on the results found. So the resulting ontology, IDEMO ontology, contains 50 classes, 25 object properties, 15 data properties, 687 actions, 546 logical actions, and 251 concept instances for the 100 overcrowding situations. Each object properties and each data property has an instance for every situation cases. So the SRL rule that are created by the SRL tape and protege tools are generated with the GIS inference engine. The rules based contain the rule base contains 50 semantic rules. And then the description and validation of the established work is based on the evaluation of the created ontology. So For that, I create the comparative evaluation table between GA and IDOMO ontology according to 6 criteria. Which are complexity, abstraction, cohesion, conceptualization, completeness, and comprehension. According to this indicator, we can prove that our ontology presents useful practical knowledge considering the vagueness and semantic of medical information. These features are very important to put this ontology into well-functioned thesis. And finally, I completed the work by the conclusion and perspective. And for conclusion, the proposed IDOMO is the emergency department domain ontology to handle the overcrowding in emergency department service. IDOMO contains semantic reasoning algorithm throughout SRL rules to assess the situation of emergency department and propose healthcare personnel to manage them. The overcrowding estimation score corresponds to a semantically ontology-based assessment tools with a high coverage of the emergency department domain and its environment by defining all the useful knowledge. And the IDOMO helps to provide a decision support system with high performance and solve the problem of missing data. And finally, the proposed model can make an efficient combination between real and estimation data based on semantic reasons. And to improve this works, I propose to improve the OSC score by using a fuzzy logic to test the new score in real time, to implement our ontology using the current emergency department system, and to add a case-based reasoning and machine learning tools to improve the accuracy of our decision system. And thank you for attention.